So good morning, everybody. It is the top of the hour on my clock, so we will get going. There are still people joining us. Hopefully they will be all on board very soon. I'd like to welcome you to this one of the RAIN Alliance webinars. My name is Steve Halliday. I am the president of the Alliance. And before we start today, we have a few housekeeping things to go through. So we will just cover those items. Today's topic is printing and encoding on metal tags with an RFID printer. Chris Brown, the RFID Subject Matter Expert with Printronix, is going to lead us in this discussion. So let's do some of the housekeeping things. First of all, to remind you that RAIN is committed to complying fully with antitrust laws. RAIN's antitrust policy is available on our website, and we just remind you not to have any discussions about the subjects listed here. We also have a collaboration and work product policy, remembering everybody to be polite, respecting fellow participants, and not sharing any trade secrets. Again, you can access this on the RAIN website. RAIN has been running these webinars now for a while. This one today will close our summer series, but we will be starting up again on the 14th of October, and our first webinar on the 14th of October will be the benefits of using RAIN RFID in pharma and the healthcare supply chain. We have several more that we're confirming right now, including a webinar on the new RAIN market research report, which should be released this month. So we hope you'll join us for these continuing webinars in October. Some notes for all of you. We are recording this event. The presentation and the video will be available in a few days on the RAIN website. We will send everybody who is registered for the event an email with the links. You are all on mute. So that means if you have questions, you need to use the facilities of the webinar system. So at the bottom of your screen, you should see a Q&A button. Please post any questions that you may have to the presenter in the Q&A system, and we will go through that at the end of the presentation. If you have questions about problems with the webinar itself, please post those to the chat section, and Paige, who is monitoring the chat section, will try and get you answers to your problems straight away, so that you get answers and can participate in the whole session. So once again, questions to the presenter go in the Q&A section, please. And finally, just to let everybody know, RAIN and AIM have put together a virtual conference. Engage Again will be held on the 9th to the 10th of December 2020, a 2-day conference and exhibit hall. So we are currently in a call for speakers, sponsors, and exhibitors, and registration for the event should go live in 2 to 3 weeks. So watch the RAIN website and you will be able to register to attend. It is open to anybody to attend. Hopefully this will give everybody a chance to engage again with your favorite technology suppliers in the world of RAIN RFID. So we are now going to hand over to Chris Brown. As I said, Chris is RFID Subject Matter Expert with Printronix, and he's going to talk about printing and encoding on metal tags with an RFID printer. Chris, away you go.
Okay, thank you, Steve, and thank you for thank you to the RAIN Alliance for hosting this webinar. Can everybody, Steve, can you see my screen?
I can, and we can hear you very clearly.
Okay, so as Steve said, we're going to talk about printing and encoding on metal tags with an RFID printer. We're going to get into the tags themselves, their constructions, and things you need to consider. And then we're going to move on to the printers, the RFID printers, how they're constructed, and considerations in the printers. So to get started, a little bit about me. As Steve has said, my name is Chris Brown. I am the RFID Subject Matter Expert at Printronix Auto ID. I've been in the auto ID industry for it's close to 25 years now. For those of you who are not familiar with the term auto ID, it stands for automatic identification, and it basically means to use technologies such as barcoding, RFID, biometrics, etc., to automatically identify things. I've been with Printronix. I started in early 2019, so we're getting up close to 2 years now. Before that, I was with Bartender Label Software for 20 years over in Europe. For those of you who don't know Bartender, it's one of the big softwares that drive
Chris, we lost you.
You lost me. Can you hear me now?
I can hear you now, yes.
Okay. Your internet connection is unstable. Not good. We are an active member of the RAIN RFID Alliance. We definitely support RAIN. I see the problem. Okay, how is the connection now?
You sound good.
Okay. We are an active member of the RAIN RFID Alliance, and we definitely believe in what RAIN is trying to do and promote. In the lower left corner, you can see my contact information. When you get this presentation, please feel free to contact me either by email or LinkedIn. I would like to hear from you. Here's our basic agenda, very simple, only 3 real topics. I'm going to start by going through some basic definitions so that when I use those terms later, you know what I'm talking about and we're all on the same page. And then I'm going to go through the on-metal tags, how they can be constructed, and things you need to look at. And then finally, I'll move on to the RFID printers themselves. So getting into the basic definitions, picture 1, you can see what we call a smart label. It looks just like a standard blank barcode label. These are rolls of labels that you put into a barcode label printer. But with a smart label, you can see in the graphic sandwiched under the face of the label, you can see that antenna construction. That is the RFID portion. And so these get loaded into a printer. They get printed with the barcode information, but at the same time, the RFID portion of the label also gets encoded with RFID information. So that's a basic smart label. On the right side, you see a fairly typical roll of on-metal tags or on-metal labels. Conceptually, they're the same thing as a smart label. It's a roll of labels that you load into an RFID printer. You run them through the printer and you print the barcode label portion on the on-metal tag. And at the same time, you are encoding the RFID portion of the on-metal tag, which is not visible here, but it's just underneath the face stock of the label. It's important to note there are a few differences here. So with the on-metals, you can see not very well from the picture, but they are significantly thicker than your standard smart label. And that's a key thing we'll be talking about later. I also have listed there some other terms, anti-metal, mount on metal, or metal mount. Depending on what geography you're in or with whom you're speaking, somebody might use one of these different terms, but they all mean the same thing. And here at Printronix, we use the term on metals. RFID printers, number 3 here. You see a picture of a fairly typical barcode label printer there. That just happens to be one of ours. For those of you who don't know, there are millions and millions of these out in the world. Any big warehouse or transportation and logistics facility will probably have at least a dozen of these, sometimes many hundreds. These printers print barcode labels by the thousands at very high speeds. An RFID version of one of these, you basically take the barcode label printer and you insert an RFID radio into the printer so that as the labels are running through the printer and being printed, the RFID portion of those labels is also being encoded. There are not millions of the RFID versions out there, but there are, probably a couple 100,000. And the final thing I want to clarify is RAIN RFID. Of course, this presentation is hosted by RAIN, but the particular type of RFID we'll be talking about today is RAIN RFID. There are many flavors and technologies of RFID out there in the world, but we are focused solely on RAIN RFID. I have other terms listed below. You may hear these other terms out there, such as UHF passive, or EPC Gen 2, or ISO 18000-63. These are all essentially RAIN RFID, and we and RAIN RFID and the RAIN Alliance are trying to promote the use of the simple term RAIN RFID over all these other confusing possibilities. So we're going to get into the tags here. Let me just make sure I double click there, excuse me. We're going to get into the on-metal tags now. So the first thing you want to do is start examining the application where the tag will be used. We have in here complete with exclamation mark. We definitely recommend working with an on-metal tag manufacturer. So you want to have a dialogue with the on-metal tag manufacturer when you are selecting your on-metal tag. You want to go through things such as the chip requirements, what kind of memory do you need, what kind of specifications should the chip have, and so on. These tag manufacturers have been through this many times, and so they know what questions to help you through. You're going to look at the surface material, meaning the material on which you will apply the tag. Maybe it's iron, maybe it's steel, maybe it's aluminum. They will know which tags should be used in which cases. You want to look at the submaterials. By that I mean you may have a steel drum, but inside of that steel drum might be a petroleum-based product or might be a water-based product. Again, they've been through this before and they can help you pick the correct tag. The curvature of the surface on which the tag will be applied. You need to look at both axes, the X and the Y axis, to make sure that where you apply your tag, the tag will still work properly, even though the tag may be curved. If you look at the bottom left picture there, the service yard asset tracking, you can see some on-metal tags attached to some steel pipes. So they're going to have some curvature along the short dimension of the tag. You could also apply the tag rotated 90 degrees, but then you're going to have to check the curvature of the tag along that axis. The read range. Most people automatically assume that a longer read range of the tag is better. That's not always true. So you want to keep in mind that you might want a shorter read range. The temperature range. Here, I mean the temperature range in which the RFID needs to work. The temperature range that the tag needs to survive is a different thing. So you want to check and make sure that the tag can be used from an RFID perspective in the temperature range that you're looking at. And finally, there are probably and possibly other considerations that you need to take into account. So make sure to check with your tag manufacturer and ask about those considerations. At the bottom of the screen, I have some typical applications for on-metal tags that we see out in the world. I already mentioned lower left, the service yard asset tracking. Remember, this is probably going to be outside, subject to outside temperatures, rain, snow, sun, and so on. In the middle, IT asset tracking, very popular use for these on-metal tags today. For example, we have an application with a school district, about 5,000 laptop computers, and they need to label each and every one. In the lower right, a particularly interesting application is aviation parts marking. There is something called ATA Spec 2000, which defines the RFID labeling for this application. Do you want to be in line with ATA Spec 2000 and so on? Well, this is a very complex application, so make sure to find a tag manufacturer who has experience manufacturing tags for this application. Moving on, you want to look at the tag dimensions, the width, the height, and I'll get to the thickness in a second. There are many different on-metal tag manufacturers out there, and I can connect you with them if you would like. They will have products commercially available that'll have a fixed width and height. You may want a different fixed width and height. If so, those manufacturers can make tags like that, but you're going to face issues such as increased cost and delays getting that tag designed. So be prepared. You may have to make some compromises when selecting your tag. You may not get exactly the width and height that you would like if you're going to go with a commercially available tag. The thickness of the tag. This is a big issue with on-metal tags. I have listed there 0.8 to 2.2 millimeters. This is a fairly standard range for on-metal tag thicknesses. It's nice to get a thinner tag. It makes the labeling less bulky, but keep in mind that as a general rule, the thicker the tag, the better on-metal performance it will have. So when you're selecting your tag, do keep in mind the tag thickness. And I'm going to come back to tag thickness later when I'm talking about the printers. And finally, you want to look at all of the traditional non-RFID media considerations, just like you would look at when you're selecting a non-RFID label. What kind of face stock material do you want or do you need? What color do you need? The adhesive requirements. Does it need to be a permanent adhesive or a removable adhesive? And then you want to look at the environment that the tag needs to survive. I'm not talking about RFID here. I'm just talking about the tag environment in general, sunlight, temperature, moisture, and so on. On the right-hand side, you can see a fairly typical dimension spec sheet for an on-metal tag. And again, at the bottom, pay attention to that label thickness, which we have labeled as label depth. With on-metal tags and using them with a thermal printer, with an RFID printer, you want to pay attention if the labels have a bridge between them. Some tag manufacturers call this a spacer. We use the term bridge. You can see in the bottom left picture a typical on-metal tag with the bridge between the labels. And on the right is not a very clear picture, but it's an on-metal tag that comes on a roll and it does not have a bridge. If you have a choice, we recommend going with a tag that has a bridge. The good news today is that most of the newer on-metal tags coming out will have this bridge. This bridge is important because it helps the labels feed through the RFID printer. Without the bridge, there's a big gap, a big jump, and the print head bounces up and down, and it's more difficult for the printer to feed and backfeed the label. So you can still see a lot of these no bridge tags out there on the internet, but we recommend getting a tag with the bridge. The bridge also serves another function, which I will discuss a little bit later in more detail, but for now, the bridge helps create distance between the tags. That's called pitch, and by increasing that distance, it makes it easier for the printer to find and work with a single tag as it's running through the printer. This is called singulation. So the printer can more easily singulate a specific tag and know which tag to print and which tag to encode at any given time. Different possible constructions. There are many different ways which these tags can be constructed. I have here which will work with which printer. Well, you never really know until you've thoroughly tested. We recommend contacting the tag manufacturers. They have taken their tag designs and tested them with many different printers. And we also recommend contacting the printer manufacturer. Has the printer manufacturer tested these tags with their printer? I should point out that we, on our website, we have a list of tags, of on-metal tags that have been tested with our different printer models. In the bottom left, you can see a fairly standard design, which is just a bunch of stacked layers. And on the right, you see a similar design, but if you look at that little magnifying glass, you can see how the inlay, which is essentially also the antenna in this case, wraps around to the back and connects with the metal foil layer of the tag. The point here is that these different constructions can affect which tag will work with which printer. So you want to discuss this with the tag manufacturer. Which particular construction have they used for which of their various tags? They will use different constructions for different tags. And which printers does a particular tag work with? And then again, go back also to the printer manufacturer and check if a tag will work with that printer. Getting into the printer side of things, when you're looking at the printers you might use, probably the first consideration you want to take into account are the media thickness specifications. If you go back and look at the printer data sheets and brochures from a year or more ago, this information was usually pretty unclear, very often contradictory, or not stated at all. Today, the printer companies are getting better at putting into their printer data sheets and brochures what is the maximum media thickness specification that the printer can handle. I should point out here that with on-metal tags, as they're feeding through the printer, they tend to get squished down a lot. So you might have an on-metal tag that is spec'd at 1.5 millimeters, but it will work in a printer that is spec'd at only 1.2 millimeters. So if you really want to use a particular tag with a particular printer and the tag is thicker than the printer should be able to handle, go ahead and test it anyway. It may very well work. It probably will. It'll just be out of spec. Okay, so keep that in mind that it could be out of spec. Moving on to the printer antennas. So these printers will have 1 or 2 encoding antennas in them. And these are the antennas in the printer that connect with the individual tags as the tags are running through the printer. And these encoding antennas will connect with the tag and transmit the data to be encoded to that particular tag. In the picture below, you can see the internal antenna, which is below the label path, and you can see the other antenna we have, which is an external antenna above the label path. Whether the antenna is above or below the label path can be very important with the on-metal tags. The on-metal tags very often have some insulation and or a metal foil layer that will prevent the below path antenna in the printer from properly communicating with the tag. So you want to make sure that you're using the proper antenna for that particular tag. Again, it comes back to testing, testing, testing. We definitely recommend using an above label path antenna for the best results. We designed it specifically for that purpose, but you could still sometimes use the below label path antenna. So before you pick up an RFID printer, check what kinds of antennas it has and where they are located. The label or tag pitch, the term pitch used to have one simple meaning. It basically meant how high is the label plus one of the top or bottom gaps. With RFID, that term got a little confused, started to mean some different things, but fortunately we're going back to the original simple meaning. When you're looking for an RFID printer, you want to look at what the minimum pitch that printer can handle is. For example, our printers can handle tags with a minimum pitch of 0.625 inches or greater. And what that means is that the tags have to be 0.6 inches or greater in height. Fortunately, with RFID inlays these days, the antenna of the inlay makes for a relatively big label or tag, so 0.6 inches is usually good enough. But you want to make sure that the labels you're getting and the printer you're getting, that the pitches will align and work together. The next bullet point here, you want to look if your RFID printer supports an RFID auto calibration feature. If you've been working with RFID printers for a long time, it used to be a very, very cumbersome, difficult, and it still is with some printers, used to be a very difficult process when you got a new RFID label or tag and you wanted to use it with the printer. You had to get very complicated specs from the label manufacturer and from the printer manufacturer, and you had to manually put these into the front panel of your printer. Well, with this RFID auto calibration concept that is emerging, when you get a new tag, you load it into your printer and you just push a few buttons, and your printer will automatically determine which chip is being used, where the RFID inlay, the RFID portion of the label is located, and what the best write and read powers for the radio are. So the printer will do all of this by itself. So we definitely recommend looking for a printer that has an RFID auto calibration feature. This next bullet point is a little complicated, so if you end up with questions on this, please let us know. When the RFID labels or tags are running through a printer, the printer needs to have some sequence for printing and encoding the tags. For example, the printer could first print the tag and then encode the RFID portion, or vice versa, which has generally been the standard. The printer might first encode the RFID portion and then print it. Both of these have some advantages and disadvantages. The last one, what we call encode during print, which we think is the greatest thing since sliced bread, is what we are currently doing. And what this means is that as the label is feeding through the printer will automatically perform the optimal function at that given moment. It generally means the printer will start printing the label, and then when the RFID portion of the label is lined up with the RFID portion of the printer will switch over to RFID mode and encode the RFID portion. And when that is done, then the printer will switch back to printing and finish printing that particular label. Now, this has a couple of very nice implications. First off, it minimizes the backfeed that is involved when you're printing and encoding the tags. If you're using one of the other sequences, print then encode or encode then print, you tend to get a lot of backfeed because the printer has to do one function and then backfeed the label to line up for the other function. And then when they're both done, the printer will forward feed the next label, line that up, and so on. Well, when you minimize the backfeed, you also maximize the performance. So it increases the speed and just gives you general speed overall. Another key advantage and implication of this encode during print firmware concept is that it means that the inlay placement, that's the industry term, that means where the inlay is within the label, it means that the inlay placement is irrelevant. So the printer does not care where the inlay is located. The inlay might be a little more forward or a little further back in the label. This is a big deal with standard smart labels. Imagine a big 4-inch by 6-inch shipping label, and that inlay could be in an infinite number of locations. But with on-metal tags, it's particularly important because with on-metal tags, the manufacturers do not have the luxury of moving the inlay location around. The inlay location is what it is, end of story. So if you're using this firmware, we don't care where that inlay is. You're always going to get the maximum performance. Next big bullet point here. You want to make sure that your printer supports high memory chips and tags if you are going to use high memory chips and tags. This is somewhat common with on-metals. The picture on the right is a tag from a particular manufacturer, not a manufacturer, but a particular company called Tego. It's an on-metal tag that commonly gets used in aviation parts marking. And it has 8 kilobytes, not bit, but 8 kilobytes of user memory. Not all printers can encode that much memory to the user portion of the tag. So if you're going to be using a high memory tag like this, you want to make sure that the printer can do that and that the printer supports some particular commands and functions that are often used with these high memory tags. For example, permalocking a specific range of user memory. So the printer needs to be able to encode that much memory, and the printer needs to support the commands that get used in that world. Once you think you have a printer and tag combination selected, then you want to move on to some testing. Very important to test the media feed, and I'm talking about the physical feed of the media through the printer. Test, test, test. You want to look at both feed and back feed. I mentioned that we have basically eliminated back feed with our new encode during print concept, but if there is a bad tag in the batch, the printer will need to backfeed to strike out that tag so you don't use it. So backfeed is still an issue. You want to make sure in your tests that the tags can go through in both directions without snagging, without peeling. You want to look at all the different edges. These on-metal tags are much thicker than smart labels generally, so they have very abrupt edges between the tags and the release liner. You want to make sure that those are passing through all of the media guides without snagging. Robust feed mechanisms needed with on-metals. We have 3 RFID printers, and in theory, as you move up the ladder in our product lineup, those feed mechanisms get more robust and more tolerant. So if you're working with a very difficult tag construction, the physical tag, you might need to go with a more expensive printer to handle that physical media feed. Moving on here, the ability to handle both on-metal tags and standard smart labels from the same printer. You may be using your printer for just on-metal tags, fine. But if you want to be able to also do standard smart labels with that printer, you want to ask, does the printer allow for you to easily and quickly switch between the two very different media types? Performance and speed. We are not at the same level of speed as we are with standard barcode labels, with RFID labels. We're not there yet. We probably won't be in my lifetime. But for many of these on-metal applications, printing speed is a critical factor. So you want to start by looking at the standard specifications for speed on the printers, the specifications that will be listed in the data sheets and in the brochures will not be for RFID, but you can get a general idea of how fast this printer is relative to that printer. Then once you pick out the speed that you need, then you can start testing and see what speed you actually get with RFID. Supported printer languages and emulations. All of these printers, these barcode and RFID printers out in the world, operate on some language or other. All the companies have their own language, but we also have what we call emulations, meaning you can use our printer based on the language from a different company. If you are setting up a new application, it's usually fine to go with the language from the printer company, and usually recommended to do that. But it can be the case where you're trying to put one of these printers into an environment with a host system that is already pumping out a different language. So you want to make sure what language that is, and does the printer you're looking at support that particular printer language. Getting into print quality, which is a pretty big issue with these on-metal tags. The best starting point here is to choose the proper ribbon. Check with the tag manufacturer and even the printer manufacturer. We've all done tests. We've tried different ribbons, and we have all found that usually a resin or wax resin ribbon will give the best print quality with these on-metal tags. If somebody recommends a particular brand of ribbon, don't feel that you have to be locked into that particular brand. All these ribbon manufacturers make roughly the same products. So if somebody recommends brand X with a wax resin combination, feel free to look at brand Y and their wax resin combination. To get the best print quality, you also want to check out the printer settings. So first up is the speed. By this I mean the print speed. As a general rule, the faster you're printing, the lower the print quality. So you might need to dial down the print speed to get an acceptable print quality. Most of these printers also support something called slew speed, and that is the speed at which the printer is feeding the labels when the printer is not actually printing. So the speed that's used in the gaps between the labels. I mention this here because sometimes you can slow down the print speed, but keep this slew speed relatively high to give you a better overall speed. You might need to monkey with we call it intensity, some people call it darkness, some people call it heat. This is the amount of time that the printhead elements get turned on or off. The longer they're turned on, the more they burn the ribbon and produce a darker image, but of course you can go too far and you can actually melt the ribbon. So you want to dial up or down that intensity to get the best print quality without melting the ribbon. Printhead pressure. This is a big one with on metals. Almost all of these printers will have some physical manual dials next to their printheads, and you can dial those up or down to manually increase or decrease the printhead pressure. Very common with on metals that you might need to adjust the printhead pressure. Finally, the graphics handling. Not sure I should have this in here. When you're sending the print job to the printer, the same label design can be sent down to a printer with many different language commands. You want to minimize the amount of things you're printing as graphics, and you want to maximize the amount of things that you are printing with, we call them device-based commands. For example, barcodes, those can be printed either as a bitmap graphic or a bunch of line graphics, or as a device-based barcode. A device-based barcode is a simple command that says, print a barcode of this type in this location with these data, go. So check your print code, the code that you're sending to the printer, and try to minimize the graphics that you're using. If you have questions on this, if you're using a label software, they have a lot of experience in this, and we as a printer company have a fair amount of experience too. Moving on, data reporting functionality. You want to make sure that your printer can also record the data that you are printing and encoding to the RFID tag, and subsequently send those data back up the pipe to some kind of a host system or database. It's very common and normal when you're printing and encoding RFID labels that you do not want to just print and encode the label and that's it. No, you want to keep a record of what has been printed and encoded on those labels. So make sure the printer supports this type of reporting. And finally, I don't like bringing up troubleshooting, but what kinds of tools does the printer and the printer manufacturer support for troubleshooting problem tags? For example, we have a browser-based interface that you can look into the printer. Let's say you have a tag that's only encoding 60% of the time, and you want to figure out why it's only encoding 60% of the time. We can guide you into this tool, and we can look at very detailed information on what's going on, and we might be able to make a setting adjustment in the printer and overcome that problem. So that's it, I think. I guess we move on to the Q&A session now. And Steve will take back over and host the Q&A session. Thank you.
Thanks, Chris. We'd really like to thank you for giving the presentation this morning. Let's see if we can answer some of these questions that we've got. Let me see here. So we've got a few questions. If people have other questions they'd like to post in the Q&A section, they can do that. So a few of them, let's see, just sorting in my mind. Okay, so let's just start here from the beginning then. So we know that RAIN inherently supports anti-collision, so you can read multiple tags effectively at the same time. Does the use of a RAIN on metal tag change any of those parameters?
Absolutely not. So whether it's an on metal tag, a smart label, or a hard tag, as we call them, like a little plastic encased tag, that is not relevant here. So that does not change things.
Okay, good, thank you. So can you give us some idea of how fast a Printronix printer could encode 96-bit TPC labels?
96-bit is very fast. That's a very easy, low encoding requirement. I tend to think of these things in terms of inches per second. And so to get an acceptable print quality and do a 96-bit EPC, I think we're looking at about 6 inches per second print speed. I don't think that really answers the question. But
well, I think they can calculate for what they want. I understand what you're saying. You can extrapolate based on your label size as to where that goes. That was a good answer. We had some questions about printing while encoding. I don't know how much more you can explain rather than what you did explain, but maybe you have documents that you can share and the people that were asking those questions can contact you for detailed documents. Is that possible?
Is this relevant to our encode during print concept?
Yes.
We don't have actual documents. We don't really want to publicize that stuff, but although I've just done that here. So I would say each person should contact me and I can work through it with them and make sure that they understand.
Okay. So you'll get Chris's contact details when you download the slide presentation in the next couple of days. So which is better, print and encode or encode and print?
We generally say that we think the best is encode during print, but if you have to use one of the other two, we think that encode then print is best. And the reason for that is if you have a bad tag, identify it before you've.
Okay, Chris, I think we might have lost you.
Did you lose me again? Oh,
we did.
I'm still here.
You're fading in and out.
Okay, everything looks okay. How's it now? Testing.
Still fading a little bit. Why don't you try and answer? Let's see what happens.
Question was, which is better, print than encode or encode than print? We favor, of course, we're doing it which is encode during print. But if you have to choose between the other ones, we would probably favor encode first and then print. And the reason for that is because if there is a bad tag, then you can identify it before you have actually printed the label.
Okay, good answer. So what about printer languages? Are there standard printer languages or does each printer manufacturer have their own language?
So each printer manufacturer has their own language. Ours, for example, is called PGL, Printronix. I think it's graphics language, even though it's not really a graphical language. And other brands have their own languages. Again, if you're starting with a brand new application that's in a standalone environment, we would recommend using that printer company's own language. But most of these printers will also emulate, meaning support, other companies' printer languages. So for example, with our printers, when you're getting things set up, you would go to the front panel and you would say, which language do I want to use? Well, I want to use competitor A's language, and you would select that. And you would do that in an existing application, an existing environment where that language is already being used. And this allows you to plug and play different printer brands into an existing environment.
Okay, is there any standard SDK or DLL that's available for Printronix printers to integrate into an application?
No, that's an extremely complicated question that goes back to my software days. We do have some tools. I'm trying to think how to answer this and keep it simple. We do have some tools, but in general, the Printronix world, which is where I am now, the printers are designed to be a little bit dumb. And that means that all of the action, all of the print job is going to occur at the software level, and then you're going to produce the print job and send it down to the printer, and the printer handles it. By making the printer dumb, that means you can process that print job faster and more efficiently. The negative of that is that you cannot easily do things like run standalone applications within the printer. So I'm not sure what purposes you would want the SDK for or the tools, but yes, we do have a multitude of tools, but they are generally not designed so that you can make an application that runs in the printer. I don't think I answered the question. But,
I think you did a good job, yes.
Okay.
I'm sure the person who asked the question can contact you direct if they have more specific questions.
Okay.
Earlier when you were talking about 6 inches per second, does the printer still pause the media to encode? Does that timing including pausing the media?
Okay, great question. I have not checked our very latest firmware yet. So the way our firmware is evolving when we're doing this encode during print, initially there was a pause, and then the next firmware made that pause shorter, and eventually there will be no pause. I don't know if we have that yet or not, but that's the direction we're moving. So it's longer pause, moving to shorter pause, moving to no pause. Okay,
good answer. So some of our remaining questions are very specific, and I'm going to answer some of them. So one of the questions was, how much is an RFID printer? Well, if you want to know how much they are, you need to contact the printer companies themselves. We're not going to talk about prices on this webinar. And we were also asked to suggest some tag manufacturers. You can go to the RAIN website. If you go to the member directory, you can filter it for tag manufacturers, and it will give you a list of all of the RAIN members who are manufacturers of tags. So you can find that one quite easily for yourself. Are there mobile RFID printers available that can print and encode on metal labels?
We, Printronix, do not have one. We are evaluating the need for it. There are a couple out there from one particular manufacturer. So yes, they are available, but they are not common.
Okay, and the last question that I have here, and I think that we really have time for today, is much more of a generic question. So if there's a stack of pipes with on metal tags on these metal pipes, how do you read the tag in the middle of the pile?
Very good question. That gets more into the application side of things, which I am not an expert, but the answer would generally be you cannot.
Yeah, I think there are ways to assist you doing that, but it depends a lot on the metal that's surrounding the tag. We all know that metal is not truly radio frequency friendly. And if there is sufficient metal in the way of the tag, you won't be able to read it. But there's also radio waves bounce off of metal, and sometimes it's possible to see a chip that you would have thought you would not be able to read. I got one more, and we still do have 2 minutes. Generally face an issue in printing where the actual RFID chip is located. Is there a solution for this other than change the print design?
Sorry, could you repeat the question?
So the person is asking, chip location in the label has caused him problems with his label design. So is there any solution to being able to use, design a label without regard to where the chip is?
Yeah, that's a very good question. I probably should have had that in the presentation. So with standard commercial on-metal tags, the chip is going to be where it is. Now with on-metal tags, you do not generally get that big obtrusive bump that you do with smart labels with the chip. So with on-metal tags, the chip is less of a factor in the label design. The next part of the answer is go to the tag manufacturer and they can, for a price, they can custom design on metal tags and probably put that chip in different locations that'll give you a surface that you can use for your label design. With standard smart labels, remember that inlay can be, imagine a 4x6 shipping label. That inlay can be pretty much anywhere. And if you're using it's not a sales pitch, but if you're using a Printronix RFID printer, because of our encode during print approach, we don't care where that inlay is. So go ahead and tell your label manufacturer to move that chip, the inlay, into some location that you don't need for your label design.
Okay, good answer. And the very last one. Do you require that a barcode is printed on each of your labels, or can it just be simple text, or can it be no printing at all and just encoding?
We do not require a barcode on there. You can print simple text, you can print nothing. It is common to run these through a printer and print nothing. You're just encoding the RFID portion.
All right, Chris, thank you.
Okay.
We really appreciate you giving this webinar today. Everybody on the call, if we didn't get to answer your questions, because of course now there's a lot of questions coming in, we will try and get you answers to the questions. For now, that's the end of today. I remind you again about the virtual conference that will be presented on the 9th and 10th of December, where you'll get a chance to learn a lot more about some of the applications and uses of RAIN RFID. Watch the RAIN website for an announcement for registration, which, as I said, should be in the next 2 to 3 weeks. So thank you again for attending. Our next webinar will be in October, and you will see some information about that in the near future. Thanks, everyone. We appreciate you being here today.
Yep, thank you.
Bye.
Bye.